Alright, we're at, for example 10, we're asked to solve the equation 9 times sine squared theta minus 6 sine theta equals 1, and we're asked to solve over the interval from 0 to 360 degrees. So if we think about this in terms of algebra again, we would have 9x squared minus 6x equals 1. So the first thing that I would try to do is bring everything over to one side and try to factor. So let's try that. Let's subtract 1 from both sides. And if we were to try to factor this, we would try either 9 sine theta, or we could try 3 and 3 sine theta. So we're going to run into a little bit of a situation here because this, no matter what we try, is not going to factor. So you can try all kinds of things, but it's actually not going to factor. Now if something doesn't factor when we are in algebra, what do? Well, we would use the quadratic formula. So once I get everything over to one side, 0 on the other, and I try to factor that, if it doesn't factor, we would use the quadratic formula. So let's remind ourselves of what that quadratic formula is. That would be x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So we were in algebra and we tried to bring everything over to one side, 0 on the other, and we tried to factor that, and we couldn't factor it, then we would say x equals all of that. Now in this analogy, x represents sine theta. So if we were to actually use the quadratic formula here, the a is, of course, whatever's in front of x squared, or whatever's in front of sine squared, that would be 9. The b would be whatever's in front of the linear term, which would be minus 6, and the c always represents the constant, which would be minus 1. So instead of writing x equals or theta equals, excuse me, we want to be careful. Over here in our analogy, x represents sine theta. So if we go back and replace that, what we're actually solving for is sine theta equals, what we're actually getting is a sine value. And we have to determine the angle that would have this sine value. So let's use our quadratic formula here. That would be minus b, so minus a minus 6, plus or minus the square root of b squared, so that would be minus 6 squared, minus 4 times a times c all over 2 times a. So you do need to know the quadratic formula just like you had to know it in college algebra. Now we're going to simplify this, but we don't have to worry about simplifying it too much because we're just going to put this into our calculator as it is obviously an unknown sine value. So let's just simplify. Minus 6 is positive 6 plus or minus the square root. Negative 6 squared would be 36, and that would be plus 36 all over 18. Let's simplify just a little bit more. We have sine theta equals 6 plus or minus the square root. 36 plus 36 is 72 all over 18. Now we're going to stop simplifying there because we're going to let our calculator do most of the work for us here. Now keep in mind that we do have two sine values because we're looking for plus and for minus. So let's separate these. Let's think about this as sine theta equals 6 plus square root of 2 over 18. And then sine theta equals 6 minus the square root of 72 all over 18. So that plus minus separates into two separate solutions. So what we're looking here, since this is an unfamiliar sine value, let's put this into our inverse function. Now, what I recommend doing in your calculator is go ahead and type in this value by itself first. So in your calculator, before you go and use the inverse function, type this into your calculator first. And we're going to work with that approximation. And you're going to leave that in your calculator and let your calculator store all of that information for you, so we don't have to retype it. But when I put this into my calculator, I get something that looks like this. And what we're going to do is we're going to use the answer button on the calculator to actually, we're going to go second sine inverse, and we're going to say second answer, and let the calculator use this entire value that it had stored already in our calculator. And then we're going to hit sine inverse. We're going to do all of that, put that in, and then the angle that we get for this, and make sure your calculator is in degree mode because we're working in degrees for this one, is we're going to round to the nearest, let's round to the nearest tenth again. I get 53.6 degrees there. Now that is a positive sine value that we got from using that quadratic formula. And in our unit circle, we know that sine is positive in two locations. Not only 53.6 in quadrant 1, but also we want to use that as a reference angle. So the distance from the x-axis to this point, 53.6, we're going to use that same distance and we're going to go into quadrant 2 that exact same amount. And we want to know, if we started here and went all the way to this point, what would this angle be? So we're going to have to do 180 degrees minus that reference angle, 53.6 degrees. So to find that quadrant 2 angle there, we're going to subtract from 180. So 180 minus that reference angle, we get 126.4 degrees. So here's two solutions, and we're going to find two more solutions with the second value here for sine. So once again, my recommendation is to put this sine value into your calculator first and let your calculator already have that value stored. And then once you have that value in your calculator, then you're going to hit the sine inverse button, and you're going to hit second answer, and let your calculator put everything in that it has stored in the calculator. So that I get minus 0.1380711187. So let your calculator use as much as it has already stored, so we get the most accurate angle possible. And remember that your calculator is going to give you a negative value, so that's to be expected. The inverse function, if you put a negative sine value in, it's going to give you a negative angle out for that sine inverse function. So it's going to give us a negative angle from quadrant 4. So we're going to get negative 7 point, and let's round to the nearest tenth, negative 7.9 degrees. Now keep in mind that we don't want a negative angle. We're asked to find solutions from 0 to 360. So we don't want a negative solution. So let's look at on our unit circle here. And if our calculator gives us negative 7.9 degrees and we want a positive coterminal angle to that, so we want that angle in quadrant 4, but we want to think of it as a positive angle, well, we're going to add 360 degrees to that angle. And so what we actually get is a positive coterminal angle, 352 point, I get 0.1 degrees. So there's one of our solutions in quadrant 4. And we also want the other quadrant angle where sine is negative. So sine is negative in quadrant 4 and also in quadrant 3. So if I go into quadrant 3 using that same distance from the x-axis to the angle, that same reference angle, 7.9, 7.9 degrees is my reference angle. What angle would that be? So this time we're working in quadrant 3. So I want to know what quadrant 3 angle has a reference angle of 7.9 degrees. So in this case, we want a complete full rotation, 180 degrees, and then we want to go a little bit more into quadrant 3, 7.9 degrees. So we're going to add 180 to 7.9. And that quadrant 3 angle turns out to be 187.9 degrees. So we get two solutions here from quadrants 4 and quadrant 3. 352.1 degrees, and then also 187.9 degrees. So we have a total of 4 solutions, 2 that came from quadrant 1 and 2, and then we have 2 more that come from quadrant 3 and quadrant 4.